Okay, so logarithms. What you need to know about logarithms, and you have to always remember, is logarithms are exponents. They always equal exponents. And logs are just another way to write exponential expressions. So if I have, and let me just give you the variable form here. Log, this little number is we call it a base of a equals x. So this is what we call logarithmic form. And you need to be able to change fairly fluidly between logarithmic and exponential form. So logarithmic form looks like this. If I were to change it, I'd take the base, which is the little number here. So that's a b. Remember, logs are exponents, so logs equal exponents. So this is my exponent, and it equals a. So again, be able to change from one form to the other, this being exponential form. Okay, so what we do, we have some properties with logarithms. Three main properties, actually. Sometimes they're referred to as laws or properties, but I just want to run through all three of them real quick. The first one deals with multiplication. So let's say I have the log base b of x times y. Now, because logs are exponents, if you think about when you are multiplying and you have the same base, like x squared times x to the third, you would add these exponents to get x to the fifth. So I'm going to kind of think along the same lines, and I'm going to do split this up, log base b of x plus log base b of y. Now it's important the base has to stay the same as you split up here. And what I do is if I start on the left and I move to the right, this is what we call expanding, because it's making the expression bigger. And if I start on the right and move to the left, that's what we call condensing. Okay, so if I had something like log base 2 of 5x, I could expand that to be log base 2 of 5 plus log base 2 of x. Now, I told you there was three properties. That is one of them. The next property deals with, instead of multiplication, it deals with division. So if I have log base b, this time I'm going to say dividing. Okay, and same thing if you're talking about exponents and you are dividing, when the bases are the same, you subtract. So I'm going to do the same thing here. I'm going to split these up, log base b of x minus log base b of y. I always remember this one. I look at the division sign here and think that that looks a lot like a subtraction sign, and it helps me remember to split them up. So whatever helps you remember. Again, if I move left to right, I've expanded. And if I move right to left, I'm condensing. So I showed you a expanding example before, so let me show you a quick condense. If I had, again, very important that this base must be the same. Log base 5 of x minus log base 5 of 7. I could combine these into one or condense them into one since the bases are the same, and I would have log base 5 of x over 7. Now the very last property here deals with exponents. So if you think about, let's log base 3 of x to the second power. If you think about when you raise an exponent up to another exponent, so if I had like x to the fourth raised to the second, we would multiply these two. So I'm going to take that same kind of concept here, and I'll just bring this 2 around front and multiply. And again, left to right is expand, and right to left is condense. So this is all about working with these 3 properties, or these 3 laws of logs, to condense or expand or simplify logs. So let me show you an example here where we use multiple properties. If I were asked to expand and simplify something like this, I could first split that fraction up using that property that allows me, that second property. So I would have log base 2 of 4 minus log base 2 of x to the third. Now before I look at this, because if I have just numbers and no variables there, I'm going to show you a little something you can do there. But ignoring that first one for just a second, I can also apply that third property to the second piece by bringing it around front. Now, what I was going to tell you about this one is I want you to think for just a minute. If logs are exponents, then what I really want to know is, what does this equal? In other words, what exponent do I raise 2 to the power of to get 4? What would that exponent be? And I hope you get that that would be 2, which would mean that the log base 2 of 4 is 2, and now it is simplified. A couple other little things to remember as you work with logs. One is the common log. Now a common log is when you have a log function and you don't see a base there. Okay, we know that there must be a base there because we're talking about exponents. Exponents have bases. So when you don't see a base there, it's an implied base of 10. Okay, and that's what we call that common log, or that base of 10. So your calculator, if you just push the button that says log, it's going to give you a base 10. The other very well-known log is what we call a natural log. And what that is, looks like this, ln, and we'll say lnx, okay? What this means is that it's a log and it has a base of e. And e is just that irrational number that you've learned about. There's a button on your calculator that has an e on it, kind of like pi that goes on forever. But this is a natural log, it's a log base of e. One other thing, if you have to evaluate something like this, it's not so easy just to put that in your calculator, because if you put log in your calculator, it's going to give you a base of 10. So what we do is we do what we call a change of base formula, which means we do log 5, and this is a common log, divided by log 2. And what that'll do is that will tell you what the log base 2 of 5. So let me pull my calculator up here. So if you do the log of 5 divided by the log of 2, you get approximately 2.32. So that gives me an approximation for this log. And again, if you notice on my calculator, these are base 10s. Okay, so that change of base lets you divide them and evaluate even when you have a base that's not 10.